What's up, Thor?
How's it going?
Good,
Sorry, my
good.
computer didn't want to cooperate.
It's okay. I know how that is. So, any questions on the prepare or anything?
Not really.
Hang on. I think I wrote one question on here. Let me see what it was. Well, for one, I couldn't make the Q plot. It didn't look right. I don't know how to do that. Like the one it does in the template, it didn't do the axis numbers right, and so mine was like all over the place. There was just scatters everywhere.
Trying to find out which number was it?
I'm trying to find the number. It's number 10 C or D? Number 10 D.
Yeah.
You're supposed to make a Q plot. Or QQ or whatever it's called. I don't know.
Yeah, I honestly didn't do that one. So
it's like and I know because, okay, so to me, how do you know? Okay, so the 15, it said there were 15 pieces of data. So that's not large. So and it said that in order to do the null hypothesis and all that, it's supposed to be normally distributed. So if you don't have a large sample, then, and even this Q plot isn't normally distributed. I guess it's iffy.
Yeah, it'd be iffy. I don't know.
How would you know that it's normally distributed? Is there a way that you would know that? Do you know? Because it's not like the histogram is not bell shaped. It's got kind of like two little sections, one main one, but then it's got like a dip. So I'm just trying to figure out, like I might have said, oh, well, you can't do the null hypothesis with this equation because it didn't fit all the criteria. But obviously they had us do it, so you can. And I just don't know how you would know that.
Where did you read that it has to be in normal shape?
In the video. Hang on. In the video, one of the criteria, I'm sure it was in the reading too, but again, I just printed these out like this, and it says that, it says requirements for hypothesis test for, oh,
there it is. Yeah, I found it. So the population is normally just.
It says either of these conditions are satisfied. So you have to know the deviation, and you have to know that it's a simple random sample, which the stratified sample, I think, is that, because he still picks some out of each one. I mean, out of his own clients. But then it says either of these conditions are satisfied. Population is normal or sample size is greater than 30. So I was just trying to understand how we knew that, because the sample size wasn't right.
That makes sense.
So how would we know that was distributed normally?
I think you just have to assume on this one, because it just says he randomly selected 15 of them. So maybe before he selected the 15, we just assumed that it was normal. normally distributed. From what I think, I don't know if he took like 15 from that. I don't know, the bell-shaped curve. If that makes sense at all.
Yeah.
I wonder if that's what it is. Just because it's
I
not
mean, because he's,
it's just he took 15 from it.
well, he did a simple random
Yeah.
sample, but then it said it had to meet one of the two criteria. Oh, well, I guess that's a question that I need to ask the teacher.
Yeah.
Just so we can, I just need to, because if it's something that's, I don't know, I just don't want, because like I said, I would have said, oh, no, you can't do it, that problem. And then it's like, oh, there's 12 parts to that problem. So apparently you can.
Mhm. Yep.
And then there was insufficient evidence to reject the null hypothesis on that. So I don't know.
Yeah.
Okay. Well,
Yeah, sorry. I'm confused as you are. Well, shall we start on the group quiz, and maybe that'll, if we help each other, maybe we'll answer that question.
yeah.
So,
Did everyone get the test done on Wednesday?
Yep.
Mhm.
I almost forgot about it.
Oh my gosh.
What was that?
I almost forgot about the test on Wednesday.
Oh, man.
That would have sucked.
That would have been really bad.
Yeah. Yeah.
So did it get late, and then you're just like, oh no, the test.
Yeah, so well, it was the middle of the day, so it wasn't too bad. But I just had a couple other tests opening up today for a couple of my other classes, which then reminded me that yesterday was the last day for that test.
That's funny.
So
Well, it kind of had me freaked out that it was allowing 4 hours for the test.
yeah.
Yeah, that too. Did not take that.
Yeah. Because when I took accounting, those tests took me like 3 hours.
Really?
They did. Because I just checked everything and, had to like do the, draw everything out, and just, they took a long time. They took me a long time.
I'm grateful I'm not taking accounting.
My chemistry tests take a while too.
Yeah, chemistry's tests are always big for I feel like.
Yeah, they're only like 20 questions too, and they take so long.
Yeah, because I think they had like 50 questions in my accounting class, but there was just a lot of steps. Like you had to do a lot just to get that one answer, in some of the problems.
Yeah.
So number
All right. This is taking forever to load.
Oh, really?
Yeah. All right.
So number 3 is the null hypothesis, I assume.
Yeah.
Yeah.
I expect that. So p-value. Is number 4 the null hypothesis as well?
Yeah.
You only reject it if it's lower than the lowest.
Yeah, you assume the null hypothesis is true.
Yeah.
Because it
Right.
says that like every time. Assuming the null hypothesis is true.
Yeah.
Blah, 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 blah.
Yeah.
Just like that, too.
Just like that.
Suppose the null hypothesis.
Two-tailed.
So a two-tailed test is going to be a not equal.
Right.
Because that means it's different. So that means it's going to be on either end of the applet.
Yeah.
Left tail is less than?
Less than 10, right?
Yeah.
Yeah.
Yeah. So that's the first one.
Yeah.
The right tail just greater than 10, I guess.
Yeah. Well, it would fail to reject the null hypothesis if the p-value is too high. So then that would be p-value is greater than a, right?
That's what I was thinking of and putting
Yeah.
down.
Because you know that, did you see that silly little quote that it had in the reading?
If the P is low, reject the null.
Yeah. Yeah, I wrote that down.
That's awesome.
Oh, wait a minute. No, wait a minute. But wait a minute. It says fail to reject the null hypothesis would make the p-value less than a because it would be small.
No.
So fail to reject would be less than. So p-value is less than a.
No, because you reject the null hypothesis if it's less than. And you
Yeah.
fail, you don't.
No.
If it's greater than A, you're going to leave it, I believe, right?
No, fail to reject is leaving it. So if you fail to reject it, that means the p-value is smaller than a,
No.
which is the significance.
No, if the p-value is not less than alpha, then we fail to reject the null. So if the p is greater, then we fail to reject.
I don't think so.
Yeah, I think Thor's right. Like, because like if the P is low, reject the null. That so
Right. If the p is null, you set the significance. So if the p-value is null, reject the.
yeah. So if it's lower, then
Then we reject it.
yeah,
So
it's
failing
lower,
to reject would then mean that the p is greater.
and we're gonna leave it.
It's that double negative that's
Okay, is that what it is? Because I know I got this stupid answer right down here. I'm sorry. The last question, I said because p was. Oh yeah, because p is 0.836, then we fail to reject. Okay, sorry.
no worries.
See, I said that to begin with, and then I thought about it, and that's the problem.
It's the double negative
I think.
throws us off.
So the next one you do less than A.
Yeah, so that's when it's like if it's 1 in 10, if it's tiny, then we do reject the null. That's right? Okay, yeah. I don't know why I got turned around. So that one would be the average claim amount is greater than 1,500, right?
That's
Which
what I was
one?
thinking.
I think so, since they say
10?
Are we on number 10, right?
Yeah, number 10.
Okay.
Yeah. Yeah.
concern the true mean is actually higher, so you can do that.
So it would be higher or greater than 1,500, right? Okay.
Yeah.
So which of the following would be the appropriate null hypothesis?
Is equal to 1,500.
Yeah.
Yeah.
Yeah, that's a good because the sample's high.
Yeah.
Because the population is normal.
I think it's a good assumption because the sample size is large.
Oh, yeah. Okay. I see what it's saying. Okay. For the n equals 40, sample size. That's a good assumption. That's the central limit theory for 13. Central limit theory.
Oh my gosh, I don't know.
I don't know because it doesn't tell us that it was skewed one way or the other to begin with. So I don't know if that's just large numbers.
It would
think it
just be
might-
the large numbers because,
The n, it gives us n. That's why.
Yeah.
Right?
It's
yeah, so we know that we have a large amount, and then we assume that it's normal because of that.
Hmm.
So,
Yeah.
because I think you can only justify the central limit theorem if you know that it's skewed prior to that, right?
Oh, yeah, you're right.
Because large numbers can be either. They both include a large sample size, but the central limit theorem is only when we have probably an uneven distribution and then we know a sample size and it gets closer. So
Yeah.
we don't know that.
Got it.
That's
We don't know
what
that.
I think.
Okay.
Oh, notes.
I think it's the z, if I remember right.
Yeah, it's the Z.
It is?
Yeah, it says determine the p-value based on the test statistic. Oh wait.
I
Yeah,
thought it was
compute
bar
the
X.
test. It says compute the test statistic, which is the z-score equals, and that's all of that.
Is that in the book?
Yeah, these are the notes from the video.
Or from the book? Or from the video?
Uh-huh. It was like the 5 steps for solving it. And then it's like number 2, compute the test statistic, and that's just solving for Z.
Yeah, I just looked in the book. It's z.
I'll have to
Okay.
look for that.
Okay.
All right.
Got negative 0.9.
So that's the z-score. That's what I got for the z-score. Is that all it's asking? Oh, yeah.
Yeah.
So do you think we have to put the zeros in there? Or no?
I don't believe so, but it doesn't hurt to do it again. So we do that in the other ones, and they are usually right.
When we do it?
Yeah.
I didn't do that on one of the things in the test, on like the money. And I better not have got that wrong. Because there was money. Come on.
Wait, so what did you guys get for 15?
Is that the z-score one?
Yeah, the
Yeah,
z-score.
negative.
Negative 0.9.
How did you guys
What
get
is the
that?
p-value from the
I
previous?
didn't get that. Because I did 144 minus 150. Is that wrong?
144 minus 150 divided
then-
by
40,
40
right?
divided by the sample square root of 36.
Oh. There it is. Okay, I couldn't find the n. Got it.
Are we supposed to
Okay.
mark above it
Yeah.
or below the z-score?
Yeah,
It looks like below. That's the alternate.
because she thinks it's decreased in price, right?
So
It's negative. So I have 0.184.
yeah, that's what I got too.
But then 0.184 is still greater than 0.05. So 0.184. So what inference would you make about the null hypothesis? So then we would fail to reject the null hypothesis, right?
Yeah.
Yeah,
Huh?
yeah, since it's greater.
Yeah, it's greater than the.
So our conclusion is it's going to be that we have insufficient evidence that the true population is less than 150, right?
Yeah, that should be it.
Mm-hmm. That's what they were looking for. Yep.
So rejecting the null hypothesis when the null hypothesis is true is type 1, right?
Yes, according to my notes.
Because that's why you make the significance really low, so that you don't make that mistake or whatever.
Mm-hmm.
Is 19 type 1?
Yeah.
Mm-hmm.
On number 20, I think, is it the probability of a type 2 error will increase?
Because
Yeah.
Because if you take that significance down to 1 in 100, then you're going to have less chance of the type 1 error, but you're going to increase the possibility of a type 2 error.
I thought, yeah. If you,
I put that in my notes. As A gets larger, type 2 gets smaller. As A gets smaller, type 2 gets larger.
Yeah, I remember reading that. Now I think
so then that would be the type 2 error would increase.
Yeah.
Already. I'll have to go back and read that. Or,
And then is the 21, is that just
If
0.05?
A, compute the probability of committing a type 1 error round to the second decimal place.
Isn't that just 0.05?
Yeah.
Pretty close.
yeah, I
Right?
need to go back and read
It's
it. I don't
gonna,
know.
it's 1 in 20, so which is 0.05. Is that just a trick question?
I think so. It's like the mean ones. Like, what's the mean for this one?
Yeah, on the test, I was like trying to solve. I don't know. I was trying to do it a weird way. I was like, wait, it's just a meme.
Okay, I'll submit it. I think it's my turn.
Do it.
Okay, we missed.
The last one.
No, we missed number 13.
So it is the
It is
central limit theorem?
Oh my
It
god.
is.
I
Unbelievable.
don't understand it. It didn't tell us that, so I don't know how we can assume that.
Well, with the law of large numbers, for me, like they always usually say it's already normal. I think that's what it is. That's what it is. I don't really know how else to
We missed
explain
number 7 as well.
it.
It's not like us.
Right? Wait, which is this? Does it represent the alternative? Right table.
What?
I must be
Right
backwards
table.
then.
Oh, the alternative hypothesis. Isn't that for the null?
So isn't that is greater than 10?
Yeah.
But is it the null hypothesis is greater than 10, and so the alternative would be the opposite?
No, the null is always equal.
Oh, you're right. Yeah, it is greater than 10.
Because number 6, we said that the mean was less than because it was left-tailed. So then right-tailed puts it on the other end of the spectrum.
Oh wait, I think I might have just marked the wrong one.
Mhm.
Now I look at it. I think I accidentally clicked the wrong one, so I think we were right.
Okay, good.
Okay, so you didn't have the mean was greater than 10 marked?
No, I accidentally clicked the same one again.
Oh, okay.
That's one of the
Tricky.
things off.
Okay, well, I really hate that large loss central limit theorem crap.
I do too.
Because it doesn't say anywhere that we would think that it could be skewed. So, oh well. Okay.
Yeah, I wish I knew how to explain it. I don't really know either.
Well, I feel like I have a pretty good understanding of it. Well, I thought.
Right?
Maybe that's the one I missed on the test. Who knows?
Yeah, I'm gonna go back and read a little more. I just skimmed through it, so I need to actually read through and practice a little more for this one. All right, guys, any questions? Anything else?
Did somebody resubmit it?
Yeah.
Yeah, I did.
Got 100.
Okay.
Was central limit theorem right?
Yeah.
I hate it when I feel so confident about something and then I'm not, right? Because then
Yeah.
that really is a blow to my confidence. So. All right.
Go back in and add all this stuff.
Cool.
All right.
Okay, guys. Well, I will exit. Have a good weekend.
Same to you guys.
Good luck with homework.
Tuesday.
What do you want to worry about the meeting later, or should we just set a time now and then change it if we need to?
Good idea.
3:15 works the best for me.
Okay.
But if something
can do
comes
it.
up for someone, I can.
Well, let's just plan on it so that, like we do, and then if something comes up, we can always. Because I feel like it's good just to have it on the calendar. It makes me feel better.
Definitely.
Sure.
I'm glad you brought it up. 3:15 works for me.
Okay.
Okay.
I'm good.
Thor?
Go on it.
Okay.
Cool.
All right, guys. Take care. Have a good one.
Okay. You too. Bye.